Hello, this is Dr. Nuray Kayakol speaking. I would like to explain understanding of Tesla valve. Here is the agenda. Tesla valve is known as valve without moving components. First, I will explain Tesla valve and how it works for non-moving with non-moving components, and then application of Tesla valves. These are fish ladders, T-junction, microfluidic mixing model, and pulse jet. This first three section will give you information about physical geometry of Tesla valve. Then I will give available safety analysis for Tesla valve and how it can be modified. And finally, what will be the drawbacks of Tesla valve. Not everything is perfect, of course. Even Tesla valve will have some drawbacks. Let's first learn how any valve in industry works. Now, I will explain to you ball valve. So on the left, you see dark color liquid, and then it stops with a ball. This is actually a screenshot. I took it from the working principle of solenoid valve. When the electricity is applied, magnetic force will be released with the this spring. You see the direction of F force is to the right. That is at the time of zero. Force on the ball will be released. Later on, you will see the dark blue liquid will try to move from the flow passages between this conical shape and the ball. You see flow is coming around the ball and then moves towards the right. At time is equal to Tn, you see a liquid will move fully from left to right. You see the liquid flowing on the right-hand side. At this time, the solenoid valve will be closed. F is in the opposite direction. Ball will move to the right, then flow stops. As you see, this is the typical valve operation. If you want to stop the flowing of liquid, you move the ball from left to right to open, right to left. So this is typical valve used in industry. What is the problem with this? First of all, because there is a moving component that is the ball. So, and wear will be where the ball is touching to this conical shape, and then the cavitation. If this liquid pressure is high during the moving ball process, liquid can evaporate. That means the liquid pressure will be below vapor pressure of liquid. Then bubble will start, and then there will be a vacuum. We will have two-phase flow instead of single phase, that is the cavitation. So these are two problems of ball with ball valve because of the moving components. So how we can get rid of these drawbacks? Can we use or develop a ball without a moving component. Now starts Tesla valve, which has no moving components. Nikola Tesla is known as electrical genius, but he has very good hydraulic knowledge. So this is the Tesla valve. Pay attention to the date of the patented this apparatus in 1920. Almost 100 years, more than 100 years ago. These are the number. If you type this Nikola Tesla US patent with this number, you will see the details of this Tesla valve patent. So I will try to explain what it is. This is the original picture from Tesla valve patent. Here, flow will move from left to right, right to left. That is two flow directions valve. As you see, there are some patterns on the geometrical shape of this pipe. Actually, some obstacles is replaced with a certain pattern. If you follow these arrows, flow is coming from the inlet. You see it will move around these obstacles. So if a flow move around something, that means it is going to slow down. There is a flow restriction on the left-hand side. Flow will move from here and then goes through this outlet, but the mass flow rate will decrease. So this is supposed to fully close this flow passage. On the other hand, if we send this fluid from right-hand side, as you see, just follow these lines. There will be not enough inertia to follow this blockage in this time. Then flow will go through like a pipe flow, straightforward. So there will be a less resistance flow. This is the main flow pattern of Tesla valve, but we will see in detail. Here is another screenshot from Tesla valve. Why this part is added to the steam turbine patent of this Tesla. You see, I have shown in this red circles. If you are interested in, we can also check this invention of Tesla. Here, flow will come and rotate the disc, circular disc. Because of the very high speed of rotation of disc, there will be a pulse and vibration. So some fluid may come back, so it shouldn't happen. So then Tesla is added this Tesla valve, so that flow will move in one direction, but not in the opposite direction. So on the right-hand side, you see internal details of the Tesla valve. So you see some obstacles look like airfoil, not exactly, but similar. So it is put in a different shape, in a different pattern we will see in details in the coming slides, but at least you can see what they are. This is the original patent. This is the 3D printed form of Tesla valve. Let's see original description of this patent. Let me read. The broad underlying idea of the invention is to permit the free passages of fluid through a channel in the direction of flow. So until now, free passages of fluid through channel, that means it moves in direction without any resistance. And let me continue to prevent its return through friction and mass resistance, thus enabling performance of valve functions without any moving parts and thereby extending the scope and usefulness of immense variety of mechanical appliances. This text is written almost 100 years ago, and it is very good written. So Tesla is not a fluid flow expert, but what it reads very clear, and it has this text actually written very good and understandable manner. Because in order to decrease the mass flow rates of fluid, it puts a resistance. Then it achieves valve without any moving components. If you are interested in, you can read this. It is available here. Now, let's see how it works. So Tesla valve is a two-way valve. Flow move from left to right with a high resistance. So we have seen earlier, flow will move around these obstacles. If you want to decrease the speed of flow, what you are going to do, create a geometry so that it can move around something. So when it moves, a curvature, it is going to slow down. That's why from left to right, flow will face high resistance. On the opposite side, from right to left, so flow will move and then does not feel the presence of these obstacles. It will move as if there is a circular pipe. So there will be no resistance or low resistance. So from the right to left, like a pipe flow, there will be no decrease in mass flow rate of fluid, but on the top, because of the high resistance, mass flow rate will decrease. That is the basic idea of Tesla valve. Now, we will continue reading the original description of the patent. I want to read because it's very good to read original patent written more than 100 years ago, and it is understandable. So one of the reasons people can admire to Tesla, Nikola Tesla. The invention can be embodied in many constructions, greatly varied in detail, but for the explanation of underlying principle, it may be broadly stated that interior of the conduit is provided with enlargement, recesses, projections, baffle buckets, which I want to stop here because because this is a patent, you know, this is not a text description part. So patent has certain languages. So when you define an obstacle, you need to give several names or similar names so that when people, how can I say, copy your patent, may say different things. So you have to cover all these, says, buffles, buckets, whatever. So this is how he described this Tesla valve shape in the language of patent. So I will continue. I was here while offering virtually no resistance to the passage of the flow in one direction. He says flow from right. You see these lines. So this is no resistance to the passage of the fluid in one direction. I will continue. On the other, surface friction constitutes an almost impossible barrier to its flow in the opposite sense. So he describes the flow in the opposite direction, that is the flow facing resistance. By reason of the more or less sudden expansions, constructions, and deflections, reveals of directions, stop and starts, and untended rapidly succeeding transformation of the pressure and velocity energies. So what does it mean? Sudden expansion here, and then contractions, that is the flow in narrow area. Reversal direction. You see the flow is changing the direction. This is how flow in resistance described in the original description of the Tesla patent. So I strongly suggest read this text and try to understand on your own what does he mean. So you will also get familiar with the patent language. It is different than the language used in articles. So I will try to again explain what is written in the patent description of the patent. So he's going to describe this section 7. So I'm reading. Evidently, its approximate path will be as indicated by the dotted line 7, which is nearly straight. That is to say, if the channel be of adequate cross-section, the fluid will encounter a very small resistance and pass through freely and undisturbed, at least to a degree. So flow will move straightforward with the less resistance. So he says it will be undisturbed because there are, so we are supposed to flow from right to left like a pipe flow, that is a circular pipe flow, but there are some obstacles around it. There's a small chance, of course, flow stream will move around this obstacle tree. So at least he's very honest, says fluid flow, mass fluid flow will not decrease, but at least to a degree. So there is still a chance, maybe at very low flow rates, perhaps liquid streamlines have energy or momentum to move around this obstacle. There's a small chance, but if the mass flow rate is very high, so because of the momentum of the fluid in this direction, there will be no time to move around this obstacle, and flow will be like a pipe flow. As you see, Nikola Tesla described this fluid channel flow in a very good manner, like he's an expert on fluid flow. Now, let's see how he describes flow with the resistance. So I'm going to read this description of the patent. Not so if the entrance be at the opposite end 4. So this is number 4. In this case, the flow will not be smooth and continuous, but intermittent, the fluid being quickly deflected and reversed. He means this part. You see, flow will be deflected. That means it, because of the shape of this baffle, you see there's a very narrow, like a triangular part. So flow coming from the part 4 will move around this triangular shape, and then flow will be deflected. And then he says reverse. That means because of the curvature of this obstacle, flow will move in this narrow section and then moves around. So I will be here, deflected and reversed in the direction set in the whirling motion, brought to the rest again accelerated. This process following one another in rapid succession. So here, what does it mean, whirling motion? You see, flow will move in separate directions. One on the top will move around this obstacle. The other one, because of you see, this is not a straight, but so there it goes up and then down. So it directs the flow stream to the entrance of the second passage. So this streamline and that streamline will collide. There will be vortices, and then it moves directions towards the bottom because of the angle of this channel. Otherwise, it will go to the top of the third section, but it's not possible because of this small passage here in triangle shape. So flow will not easily turn around this certain triangular shape. So because of the angle of the bottom part, it will go to second part, move around the second baffle. So the aim is force the flow moving around these baffles so that it is going to lose energy or momentum. It is going to slow down. This is the main idea of Tesla valve. Okay, let's continue. Another description. Now, the partitions 3 serve to direct the stream upon the buckets and to intensify the actions of causing violent surges and eddies, which interfere very materially with the flow of through conduits. So he says because of the circular motion, because the streams are collide to each other, and then move around, so it's going to cause some eddies. So in order to slow down fluid flow, you should create some vortices and eddies and disturbance to the flow. So this is how it is done in the Tesla valve. So it's very nicely explained in the patent. So instead of reading a fluid flow textbook, you can read the Tesla valve and you can learn many things. It is nicely written. So I want to also read some other parts to describe Tesla valve. The broad underlying idea of invention is to permit the free passages of a fluid through a channel in the direction of flow and prevent its return through friction and mass resistance, thus enabling the performance of valve functions without any moving parts, thereby extending scope and usefulness of an immense variety of mechanical appliances. So it says flow will move in one direction easily without any friction, but in the opposite direction, there will be a resistance to flow. Because valve means resistance to flow. So he thinks that this invention will have a variety of mechanical appliances. Yes, indeed. So I will also share this applications video. This is another picture from original patent. So high resistance. So he shows the streamlines with an arrow, that is the flow is moving around an obstacle or baffle. Even you can call some shape of airfoil. On the right hand side, low resistance, that means flow will move directly to the other part of the or other section of the valve. Please pay attention how geometry is changed to force the flows on certain parts of the valve. For example, so here you see there is an it moves up. There is an angle. It's not a straightforward. So if you don't add this section, and suppose that this part is cut, so it's not possible to get this low resistance. Otherwise, flow, if you cut this part, flow will move down, maybe move around this one. Also, the shape of these baffles are important. So if you are familiar with the airfoil, so you might think that this blockage as airfoil type blockage. So you can give different shapes, but here it's one part is a triangle, the other is thick airfoil. You might see the similarity. So this might give you an idea about how to change this flow blockages, so that you can get different versions of Tesla valve. So these are the screenshots shots available on the internet. If you see from this is a kind of box. There are some patterns inside. This is 3D shape. This is 2D shape. It's a little bit different than the original Tesla valve, but it is going to work. This is another explanation of Tesla valve. I like very much. If you want, you can watch this video. This is a wood-carved Tesla valve, and streamlines are shown with an arrow. So I'm going to stop first part of this seminar, then I will continue explain in the second part the details of this flow pattern, especially useful for fresh safety engineers. See you there.